This is our galaxy. Billions of stars leading to one. Our Sun. The focal point of a solar system comprised of 9 planets, 8 of which are believed to be lifeless. Except for one. The only one we call home. Earth. A world home to millions of species of life and 6 billion humans living at the dawn of a new millennium. A millennium that may one day see us leave this world behind, beginning with the exploration of a new one, our nearest neighbor in the night sky. Mars, a lifeless and barren world, or is it? At this point in history, Mars is closer to the Earth than it has been in 60,000 years. So with the best opportunity to find out for certain, the National Aeronautics and Space Administration and the European Space Agency are leading the way for humanity's leap into a new frontier. They've sent 2 identical rover vehicles and an orbiting spacecraft to the Red Planet. And in December of 2003 and in January of 2004, they arrived and have begun exploring a place we can only imagine.
20 years ago, it was sort of well, Mars is dead, but we don't know that.
I think that would be profound for us as human beings to know that we are not the only living creatures in the universe. So it's been fascinating for science, perhaps fascinating for the future of humanity too.
In early June of 2003, the first of 2 Mars exploration rovers was launched. It's known as the MER project. The contained rover was named Spirit. And 1 month later,
main engine start, 0 and liftoff of the Delta rocket with Opportunity, a chance to explore and unlock the secrets of our neighboring planet.
The reason that we're flying the Mars rover missions to Mars right now is to really get a good understanding of the ancient water history of Mars.
Dave Lavery is NASA's program executive for solar system exploration.
What we're trying to find out is there proof, or at least real strong evidence, that there was standing water on Mars for long periods of time that could have affected the geology, could have affected the climate of Mars, and potentially created a habitat that was capable of supporting life.
So it's almost certain that Mars has the potential for life. But in order for us to know, we must get there first. And for the MER rovers, it's a bumpy ride.
Basically, if you were sitting on the outside of the spacecraft watching them descend through the Martian atmosphere, it would appear exactly the same way that Mars Pathfinder did in 1997. What's going to happen is we're going to hit the top of the Martian atmosphere at about 12,000 miles an hour, and then in just 6 minutes we'll go from 12,000 down to 0 as we get down to the surface. The first thing that will happen is the heat shield will absorb a lot of shock and slow us down to about 1,000 miles an hour. Then a set of supersonic parachutes deploy, slows us down even further. And finally, when we're about 100 yards above the surface of Mars, a set of airbags inflates. Just 8 seconds off the surface, they pop open, fully inflate. We cut away the parachute and then free fall the last 10 to 20 meters down to the surface. And we'll bounce around for a while in these big airbag assemblies. Could bounce as many as 20 times, may roll a half a kilometer away, but generally after a couple of minutes we'll just come to rest. We'll deflate the airbags and the whole spacecraft will settle down onto the surface, pull the airbags back in, and then the lander will sit there. It's basically all folded up, and it turns itself over and just opens up with petals just opening like a flower, and then the rover will be sitting inside. We've had a process that went on for over a year to determine what the best landing sites were on Mars for us to take these rovers to. Now, there were a set of constraints that sort of initially defined where we could go. The rovers had to stay in sort of around the equator, plus or minus 10 degrees, in terms of that central band of Mars. Because they're solar powered, we were limited to that region.
On the 4th of January 2004, Mars exploration rover Spirit landed in Gusev Crater. Then just 3 weeks later, Opportunity successfully touched down in Meridiomedy, also known as the Hematite Site. Launched just days before the MER mission, the Mars Express is the European Space Agency's Mars project. It is comprised of a sophisticated orbiter that arrived at Mars just over a week before the MER missions. The orbiter has begun to map the planet and conduct its own analysis, but on the 25th of December 2003, the craft dropped off a very special package. The British-built effort of Beagle 2 was due to explore Mars and search for evidence of life. However, no signal was received from the lander. If the craft had have succeeded, it would have conducted its analysis using a similar suite of advanced scientific instruments to those found on the MER vehicles.
The instruments on board the rover itself that are the contact instruments, these in situ instruments, are things like the microscopic imager. There's also a Mossbauer spectrometer. There's an alpha particle X-ray spectrometer. There's also something called the RAT, which is my favorite. The RAT, or the rock abrasion tool. The rock abrasion tool is basically, think of it as a little handheld grinder that we put up against the rock to grind away the weathered surface so we can see fresh, pristine rock. Then we can take these other instruments, the Mossbauer spectrometer, the APXS, and the camera, and actually look at the interior of these rocks. The panoramic camera does just what it sounds like. It's a camera that is designed to take these great 360-degree panoramas in very, very high resolution and provide those images back to Earth.
So what could the potential ramifications of finding life on Mars really be? What could it mean for humanity?
Well, the significance of finding some sort of life on Mars will depend greatly on what we learn about that life. One of my colleagues is certain that if we find life on Mars, that it'll be related to Earth life.
John Rummel is NASA's Planetary Protection Officer. He is charged with executing NASA's policy that prevents biological contamination of the solar system.
If that life on Mars is completely different than life on Earth, that would tell us something about the origin of life that would be very intriguing. Now, one of the reasons we want to go to Mars to learn about life is because rocks from 4.5 billion, 4 billion years ago are abundant on the surface of Mars. So already we can tell about something about the early solar system that we can't find here on Earth, where through plate tectonics, all those old rocks have been recycled. So we want to find out about how this life developed, and we can find that in the fossil record on Mars, and perhaps that will tell us something about how life developed here on the Earth. We're tremendously interested about life elsewhere in the universe and protecting life here. I mean, it's the only biosphere we have right now, and we like to, keep it as healthy as we can. We're doing enough damage to it internally that we don't want to bring anything from the outside.
John Rummel's job in relation to the MER mission is to prevent simple microbial life here on Earth from finding its way onto the spacecraft and affecting the scientific readings of the two rovers.
So what we're trying to do is to be able to get that payoff that the taxpayers are paying for by finding out what Mars is really like. I mean, it's not a good idea to go all the way to Mars and discover life that you could have discovered in Florida because you brought it with you. So that would be a bad thing. We know that heat kills microbes. Now we're looking at implementing large-scale techniques that use things that have been proven in the laboratory, things like hydrogen peroxide, to scale that up. So you could do it to an entire rover, for example, if you wanted to surface sterilize it. And we'll continue to look at new ways to efficiently kill off microbes without killing the spacecraft that they're on.